Let me start by running a container first. As you can see, I've just run the container and it just booted up within seconds. And on checking the OS version of that container, it just came out to be Alpine Linux. And on exiting the container and running the same command on my host machine, the version came out to be Ubuntu 18.04. On checking the image size of that particular OS, we found out that the size was only about 5 MB. But this image is not able to run our application because we haven't provided any source code to it. So in order to build our own application, we are going to build a small application using Dockerfile. As you can see, what we are doing here is just taking a number and looping it through 0 to a million and finding square root of every number and just printing OK. So the next thing we are doing is we are creating a Docker file in which we are using PHP Apache image, which only consists of PHP framework and Apache web server. And we are copying our index.php that we have just created into the container path where Apache is gonna execute it and show it to us. So now let us build our own image from the Docker file that we have just created, and here I'm doing is I am tagging my image in the format of username/image name and passing the current path in order to build it. While this image is building, let me introduce you to the concept of Kubernetes. So Kubernetes is a container orchestrator technology that enables, if there are multiple containers simultaneously running, how they should interact with each other and how their life cycles should be managed. And there are dozens of advantages of it as well. Now I'm not going to deep dive into it, and I'm just going to deploy the application that we have created and deploy it onto Kubernetes. So now that our image has been built, let us push that image onto Docker Hub. Now that image has been pushed, let us check if that image is available on Docker Hub or not. As you can see, the image is present. Now let us use this image and deploy it. Let us see what Kubernetes deployments actually look like. So Kubernetes deployments are one of many kind of Kubernetes objects that has multiple properties. But for the sake of simplicity, you only need to remember the fact that deployments only maintains replicas count of a pod. So here we are using the image that we have just created, and here we are limiting the CPU resources of a pod to 500 amps. So 500 amps should be considered as 50% of a single core processor, and we are exposing this deployment on port 80 so that other containers in the same namespace can directly access it. So now let us deploy this deployment using apply command, and our deployment and service should be created. And now that the container is in creating state, it must be pulling our image that we have created, and within no time that deployment will be in ready state. The only thing you need to focus on this deployment is that it has created only one replica. Now in order to understand different Kubernetes properties, let us create an autoscaler that will set the condition if the CPU percentage of a single pod increases above 50%, it will create a replica of it. And I have set the minimum value to 1 and maximum to 10. So it will scale down automatically if the CPU load falls below 50%. So now let us orchestrate a situation where we generate some load on the application that is running the index.php file. So here what we are doing is we are constantly executing the index.php file that we have created, that is running the square root of a number every 0.01 second. So that's gonna ramp up the CPU usage above the target limit that we have set, that is 50%. As you can see that it is printing repeatedly, so that means our script is running successfully. Now let us check if the policy that we have implemented is actually working or not. As you can see, now there are 4 PHP pods running, and if we check the policy, the stats that the target value has already been reached and it is about 200%, and it has already created 4 replicas, and it is going to create more replicas as soon as the load increases. Now as you can see that it has already created 6 replicas, and it will keep on increasing up to 10, and our auto scaling feature has been running smoothly. Now let us stop the script and check if auto scaling down feature is working or not. Now it's been 5 minutes since the script has been stopped, and let us check if the pods has been scaled down or not. As you can see, now the pods are only at 1 replicas, and there is only 1 pod running. So that covers our basics of Dockers and Kubernetes with auto scaling features. You might be wondering what is the role of our application in this technology stack. As you might have noticed that in order to build your application onto Kubernetes, you need to follow certain steps. That includes selecting the base image to run our application, and then specifying the content that you need to copy into container, and various other factors like port number, environment variables, and then you need to build a Docker file out of it and then push it to Docker Hub or any other registry, and then use that image as a Kubernetes object in order to deploy it. So that's where our project comes into play, which minimizes the efforts on building and deploying your application onto Kubernetes. So let me start by introducing you to the architecture of our platform. As you can see, I have created a load balancer that is backed by Kubernetes ingress controller. So that is the endpoint where we are going to point all our domain and subdomains in order to see what our applications are going to deploy. I have got a domain name that is phoenixapp.ga, and here I have pointed some of the subdomains to the load balancer that I have just shown you. Here we are going to use 3 of the subdomains and use it to deploy our application. As you can see, there are no services or apps running on these subdomains, so let us deploy that. Firstly, we are going to build a React application that is being created by one of my friend. As you can see there in the source code, there is no Docker file present in it, and on checking the UI of how it should look like, as you can see, this is a normal React application running Instagram's UI on Reddit backend. Please feel free to check out this application. Now that I have shown you the UI part of the application, now let us deploy it onto our platform. Firstly, I'm going to create a namespace. So namespaces are nothing but the partition in order to define different deployments. Now I'm going to execute a single command that is going to deploy our application onto Kubernetes directly. So this is just a backend command, and in the later demonstrations, I'm going to use frontend as well. Since the application has been deployed, now let us see how this application is getting deployed at back. From the command that we have executed above, this is going to create some objects like pipelines, pipeline runs, tasks and task runs, but for the sake of this tutorial, I'm going to skip that for now. But the basic idea is that it is going to create some Docker images, and it's going to push it to Docker Hub, and it's going to create the deployment out of it. Now that the different tasks and task runs have been completed, I'm sure that we will be able to see our application on rfn.phoenixapp.ga. As soon as I refresh it, application has deployed without creating any Docker file and without pushing it onto Docker Hub. We have directly deployed it onto Kubernetes. So that completes our demonstration on how we can build our own pipelines even without having a Docker file. Next up is about continuous integration and continuous deployments. For that, we are going to use another app which is running a Node.js application. We are going to deploy our application on catapp.phoenixapp.ga. As you can see, there is nothing running on it. One thing you need to notice here is the fact that we are going to use Docker file here because the purpose of this demonstration is different. So for the sake of simplicity, we are going to use Docker file. In order to deploy our application, the commands will be the same from the previous demonstration. Firstly, we are going to create a namespace, and then we are going to deploy it using the our backend command. As soon as it will deployed, we will have different objects running in our namespace, which will have different tasks and task runs getting initialized. So the only thing that differentiates it from the previous demonstration is the fact that we are going to create a webhook on GitHub repository where it will going to send the payload into our Kubernetes event listener object that is going to listen for the events such as push or commits. Now let us change some of our content on our GitHub repo. For example, like here we are going to edit from cute kitty to, let's say, hello kitty, and then we are going to commit the changes. As soon as we commit changes, now we are going to check if the webhook that we have created was successfully able to send the payload to our event listener or not. As you can see, we have successfully sent the payload onto Kubernetes event listener object. Now that event listener will trigger our pipeline and will deploy our application on catapp.kubernetesapp.ga with the prescribed changes that we have committed. That is going to create some task and task runs and will expose the pod. Now if we refresh our URL, we are going to see our application with the desired changes. As you can see that Hello Kitty has been changed from Cute Kitty. So now let us make some changes once again, and now here I am changing from hello to pretty kitty and committing the changes. Now that webhook has successfully sent the payload onto our event listener, as we can see that the pipeline has already been started. Now if we refresh our URL, we can see that it has successfully detected the changes and it has created automatic deployments out of it. That completes our second demonstration on building applications with CI/CD pipelines. And by now you might be wondering that I have already set the default GitHub URL that we are going to build. So how that could be useful for developers like us. So in this third demonstration, I'm going to show that how we can deploy our application without even having a Docker file and choosing any URL at random. For this demonstration, we are going to use any app.phoenixapp.ga. We can choose any subdomain or domain name, but for the sake of simplicity, we are going to use this. And now for the source code, we are going to use any sample HTML source code. So let me search for it. I have chosen this URL at random, so I don't know the contents of it. As you can see, there is no Docker file present in it. So as soon as there is no Docker file, we are good with it. I'm just going to copy this URL and we will use this URL as the parameter of our deployment. Firstly, I'm going to create the namespace, and like any other deployment, I'm just going to use our backend command with some few tweaks, like adding a GitHub URL and just passing the parameters that we have just copied. As soon as it is deployed, let us now refresh our URL. As you can see, our application has been deployed without even having a Docker file. So that completes our third and final demonstration on how you can build your own applications on Kubernetes. I have many more demonstrations to show, like fault tolerance and how we are handling disaster recovery of stateful applications, but due to the time limit, I am not able to show you right now. So if anyone is interested for further demonstrations, you can reach out to us personally. Thank you.